Hey everyone, today we're going to be doing a question called Is tree a binary search tree from Elements of the Programming Interviews in Python. This is a binary tree question, so if you're not familiar with a binary tree or what a binary search tree is, I'm going to put a link in the description for that. And just as a quick recap, a binary search tree is a tree such that for each node, every child recursively to the left is less than the node value, and every child recursively to the right is greater than the node value. For example, if we have something like 2 at the root with 1 at the left and 3 on the right, we will return true because 1 is to the left and then 3 is to the right. And then if we're given something like 1 with 2 and 3 as the children, we're going to have false because 2 is greater than 1, even though 3 is greater than 1 and it's on the right. Now, there's many ways to do this. You can do it iteratively or recursively. For this video, we're going to be using the recursive solution simply because it's slightly simpler. However, every single recursive function can be written as an iterative function, at least almost all the time. So we're just going to go with the recursive solution since it's a little bit simpler. So the way we're going to do it is we're going to be using in-order traversal. So in-order traversal traverses the nodes from left to right. So it goes all the way down. It checks the value on the most left, then it checks the node value, and then it checks all the values on the right. So I'm also going to put a link in the description for a recap of the in-order traversal. These are all sort of basic binary tree building blocks, and if you're not familiar with them, I would suggest to recap them and then return to this video. So with that being said, I'm going to go into the solution. So our general approach is going to be go in order using our in-order traversal, and then check the value we are currently looking at. If it is bigger than the previous sort of min value. So the way we're going to do this, I think we can use a helper function. So we're going to call this def in order, and it's going to take a node in our tree, and then we can declare sort of like a self.min, and this is going to be by default negative infinity, or int min float negative inf, and then we're going to go in order, and then at the end what we're going to call is we're just going to call return in order on the root of the tree, which is called root, or is it called? Yeah, it's called tree. So we're going to call this recursively on our tree, and then our in order search simply checks if not node. So if it's empty, we're going to simply return true. Otherwise, if we do have a node, we're going to first recursively call the left. We're going to call in order node.left. Then we're going to check that the current value is greater than the minimum. So we're going to check if node.data is greater than self.min, then this is okay. Else we're going to return false. So if it's okay, what we're going to do is we're simply going to update min to our current value. We're going to say self.min equals node.data. And then we're going to call the right because that's how our in order works. We call left, then we check our value, and then we check right. In order node.right. And here, of course, we have to say and otherwise we can just return this directly, because here, if left is true, we can't return true because one of these things might be false. But if it's false, we know for sure it's false, because if the left subtree is not valid, then the full tree is definitely not valid either. So here we can format it sort of in a way that's more familiar. And now let's review our solution here. So we've set our minimum value, we check our node. If it's an empty node, by default it is true. Otherwise, we're going to check left. If our left is not a binary search tree, then the rest of our tree cannot be a binary search tree. Then we're going to check our current value. We're going to check that node.data is greater than our self-min. And then we're going to update our min. And then we're going to call write. So let's test out our solution. And it looks like we can't do self because we aren't using an object, but what we can do is we can just say min equals, and we can call it with a list. So we can say min 0, and the trick that we're using here is basically inside our function, we'd have to either declare this value non-local, or we would have to take a pointer to it. So here, this list, we would be able to update and set this list. If we didn't set it into a list, it would just be a local variable. And self would work if we had some sort of class here. So if we were using LeetCode, for instance, on LeetCode, using self would typically work. But typically this is just a shorthand for setting min to be sort of like a global variable, or you could even set it outside. I mean, you can do it however way you want. You just want to make sure that you're able to globally update this minimum. You could either, or actually you could also pass it as a parameter. That would also be an alternate solution. So anyways, let's test this out, and looks like we are wrong. True, result false. Maybe we can let this be equal. Yeah, so this is just a matter of preference. I mean, typically a binary search tree, the values are not allowed to be less than or equal to. In the EPI judge, for some reason, they do allow it to be less than or equal to. This is sort of a nuance of binary search trees. I mean, you have to be very rigorous about the definition. But typically from what I've seen, usually binary search trees don't allow it to be equal, because that would allow duplicate values, and in a search tree you typically don't want to have duplicate values. Anyways, hopefully you enjoyed this video. If you did, please like, comment, and subscribe. And if you're looking for some personalized interview help, maybe mentorship or mock interviews or resume reviews, head on over to our website and book an appointment, or fill out the Google Docs and we will contact you shortly. Hope you enjoyed this video and have a great day.